Let's look at section 9. These are formulas that will be given you on your formula chart. First one is just a transformation. What would have happened to this if it changed to this? Well, this is your parent function, y equals x squared. The plus 4 means it moved up here. The minus 2 means it's down here. So what did it do? It went down 6 units. It didn't get wider, it didn't get narrower, because wider would have a fraction in front, narrower would have a bigger number in front, bigger than 1. Upside down would have a negative in front. So all this, remember, this is your up and down move. So this moved it down 6 units. If you don't remember anything else, please put those in Y1 and Y2 and compare. The parabolic path of a basketball being shot into a hoop can be modeled by this equation where x represents the amount of elapsed time and y represents the height of the ball. How many seconds does it take for the ball to reach its highest point? The highest point is the vertex. Now remember that the x value of the vertex is your axis of symmetry. So look up here at your formula. Now first you could put it in the calculator and see if you could find it that way. If you can't, then use your formula, negative b over 2a. b is the number in front of x, so it's negative 12 over a is the number in front of x squared. Remember, they're not always in order. Some of you are struggling with that. A is in front of x squared. Now, if I divide this, I get 2. So the axis of symmetry is 2. That's also the x value of the vertex. That's the highest point. That means it took 2 seconds to reach the highest point. What is its maximum height? So you can put it in y equals. Obviously, I could find this one in the calculator. If I couldn't, then I could substitute. Whoops, I forgot to substitute. I could put my 2 in for x. So let's see. I'm going to get 9 plus 24 is 33. 2 squared is 4 minus 12. I'm going to get a height of 21 meters. How high is the ball after 3.1 seconds? So you could put this, you could substitute the 3.1 for x. Now the other thing you could do, let me just remind you on your calculator, the other thing you could do is you could put this in y equals, and you can go to the table. Let's just check and see if my 2 was right. Yes, it is. 221 is your vertex. But I don't see 3.1. So I go second window. I type in 3.1. I'm telling my table to start at 3.1. So how high is the ball after 3.1 seconds? 17.37 meters. So either one. You can do second window or you can substitute. How long does it take the ball to reach a height of 15? Whoops. I'm going to go second window 0. That gets me back to my regular table. How long does it take the ball to reach a height of 15 meters? Well, that doesn't show up in my table, does it? So I'm going to have to set this equal to 15 and use quadratic formula. Let's reorder this because I think that would help you. So let's put the A first, then the B. Now, I've got 9 minus 15. I have to minus the 15 to have it equal to 0 before I can use quadratic formula. Now, I'm noticing I could divide all these by 3 and get a much smaller equation, much smaller numbers, but that is purely up to you, whether you want to do that or not. So if we did it like this, A is negative 3, B is 12, C is negative 6, x equals negative b plus or minus the square root of b squared minus 4ac. Can't write that fast. All over 2a. Now what I can do now is I just put it in the calculator and let the calculator do the work for me because I do want a real life answer. So alpha y equals center, negative 12. I can't do plus or minus at the same time, so I pick one. I'm going to do plus first. I'm a little bit slow typing this, guys. So, how long does it take it to reach a height of 15 meters? About 0.59 seconds. But it hits it twice, remember? Once on the way up, once on the way down. Let's just get the other answer. I'm going to change this to a minus, and the other answer is 3.4 seconds, 3.41. So 0.59 on the way up, 3.41 on the way down. All right, last section, comparing functions. Which one is represented by this? Well, all you would have to do is type these into y equals and look at the table and see which one matched. I'm not going to do that right now. Video is getting long, but just type them into y equals or substitute either one. This one would be easy to check. It can't be this because 0 squared is going to be 0. 2 to the 0 power is 1. So it's got to be one of these, and then you could check them. I'm not going to do that right now. Okay. Yes, I will. Okay. Never mind. It's A. I just wanted you to know the correct answer. Which one best represents? Guys, you could use y equals and check. This is a exponential. So exponential means x is the exponent. So it's got to be one of these. Now, these are different. I know they look the same, but they're really different. So if we went to y equals and we put 4 to the x, and then in the next one, let's put 2 times 2 to the x, and let's look at the graph. So here's the first one I put in, the 4 to the x, and here's the second one I put in. How in the world do we know which one it is? We're going to have to pick a point. Wow, this is so close, guys. I didn't even notice this. Let's look at the table. So they both have, oh, no, their y-intercepts are different. I should have known that. 0, 1, it has to be this one. I should have known that. I did a lot of work for nothing. Which type of function is represented by the table? Okay, as x goes up by 1, what is y doing? It's going down by 2. Same rate of change makes it linear.